Welcome to all of you in today's lecture. In this lecture of class 11th chapter motion in a straight line, lecture number 2. In this lecture we will discuss about the uniform motion, okay, and as a position as a function of time, okay, in this respect. So firstly I want to introduce the concept of point object. So what is point object? Actually, suppose we can say this is a route of a train, and suppose there is a train. Suppose there is a train, okay, very long train. But if this train travels a larger distance in comparison to its size, if any object means we can say here, if the train covers so large distance in comparison to its own size, then this can be regarded as a point object, okay. And suppose in any another example, suppose the motion of or the movement of earth, okay, revolution of earth around the sun, okay. So earth can also be treated as a point object. So it's not meaning that point object is an object of having very small size. No, we can consider any object as a point object if its size is very small in comparison to the distance, okay, or covered by the object, okay. So here train can also be treated as a point object. And remember, in case of point object, we generally ignore its vibrational motion and rotational motion here, okay. We will talk about the motion along a straight line, okay. So now we all know about uniform motion from class 9th, uniform motion, okay. Now actually, what is uniform motion? The motion of an object if it covers equal distances in equal intervals of time, howsoever so small these time intervals may be, then the motion is called uniform, okay. So uniform motion is if any object covers, you can write, I already explained this in the previous lecture. Uniform motion, definition of uniform motion: if any object covers equal distances in equal interval of time, howsoever so small these time intervals may be. Means uniform motion will be considered if it is applicable for small time intervals also, okay. If the object covers equal distances in a very short intervals of time, then we will call it as a uniform motion, okay. Now in case of uniform motion, for uniform motion some points are also there. For uniform motion, the point object, I am writing here, the point object has equal speed. Point object has equal speed throughout its motion. Means if any object will cover equal distance in equal interval of time, it means its speed should be constant. It means point object will have equal speed, okay, throughout its motion. And we can say that the speed of the object is constant, means remains fixed for a uniform motion. If speed is constant, then I am introducing a concept that the velocity or speed, okay. Actually you know about speed. If I will add the direction with speed also, then it is known as velocity. Means we can say speed if there is only magnitude. If direction is also, then we will say it velocity, okay. So speed and velocity both here we are taking. So speed should not be a function of time. Speed should not be a function of time. Means speed should not depend on time. Means speed should not be a function of time. Means speed v should not be a function of time for uniform motion. V should not, okay. Then if the speed is not a function of time, then the object is called a uniform motion. Now I am explaining with example. Suppose I say v equal to 4 meter per second. suppose v equal to 4 meter per second, it shows that the velocity is constant and it is not depending on time. So means at t equal to 0 second, well, speed or velocity, okay, it is 4 meter per second. After 1 second, same 4 meter per second. After 2 second, 4 meter per second. 3, 4, 5, 6, 7, 8 means as time passes, the speed is constant. Okay, means 4 meter per second. Suppose now I am writing here v equal to a function, suppose 4t, v is a function as 4t here. So it means that the velocity is depending on time. At t equal to 0, velocity will be 0. Okay, and at t equal to 1 second, suppose this is 4t meter per second, t equal to 1, velocity will be 4 meter per second. At t equal to 2, v equal to 8 meter per second. At t equal to 3, v is equal to 12 meter per second. So here velocity is depending on time. So it is not a uniform motion. Means in case of uniform motion, the t should not be there in the function of, in case of velocity or speed. Okay. So this is not uniform. We can say this is non-uniform motion. This is non-uniform motion, and this one is the uniform motion. So main concept is that speed should not be a function of time for uniform motion. For uniform motion. Okay. Now we will discuss about the position. How position is related with that function. Okay, you can note down it one. Okay, this is here. This is non-uniform motion. Why this is non-uniform motion? Because in this case, speed is a function. Speed is a function of what? Time. Speed is a function of time. So that's why this is a non-uniform motion, and this is uniform motion because speed is not a function of time. Okay. Now you can note down this one. Now suppose we discuss the uniform motion as position as a function of time. In case of position as a function of time, and then we will calculate the slope. We will discuss about the slope. Suppose now I am writing here the position of an object. Position of an object is a function of time. Means position of an object is represented as, suppose, xt. xt means, you know, I explained in the previous lecture, position of an object x at time t. Okay, suppose it is given by 3t. It is given by a function of time 3t, that is meter. 3t meter. This is a function of, this is the position of an object. Now how we can determine either it is a uniform or it is a non-uniform motion. Okay, so how we can discuss about this type of functions. Okay, and then the slope of this. Okay, so for this one, here you can check xt equal to 3t, means x is depending on time. X, position of an object, depends on time. At how I can represent here, we can make a table here, t in suppose second and x in meter. T in second and x in meter. Then t equal to 0. At t equal to 0, x 0 means 0. How we can write at t equal to 0, we will write the position of the object as x 0 equal to 3 into 0, that is equal to 0. X 0 means not the meaning of x multiplied by 0 equal to 0. No, x, the position of an object at time t equal to 0, this is the meaning. And at t equal to 1, we will write x1. We will write the position as x1, and x1 equal to 3 into 1, that is 3 meter per second. Okay, now we will write in this way, at t equal to 2, at t equal to 2 second. Okay, 2 seconds. Then position of an object at t equal to 2 second, we will write x2. x2 means 3 into 2, that is equal to 6 meter per second, in this way. Okay, so at t equal to 0, position x is 0. Okay, at t equal to 1, this is 3 meter per second. At t equal to 2, this is 6 meter per second. From here you can check, and t equal to 3 put here, then x will be 9, and t equal to 4 x will be 12, at t equal to 5 x will be 15 meter per second. Okay, so here the x is depending on time. X is depending on time, means we are having only one choice. We are having the choice of time, but position x is changing according to this time. Okay, so that means we can say, suppose there is a function y equal to x, suppose. So x is our choice, but y is not our choice. Y is changing according to x. Suppose y equal to 3x, so our choice is only x. We can put x equal to 0, then according to that y will be changed. Okay, so only one variable is changing. Motion in a straight line. Okay, we have only one choice, x equal to 1, then y will be changed according to x. X equal to 1, y equal to 3, x equal to 2, y equal to 6. So in this case, now you can see, you can check from this table, either this function xt equal to 3t is a function, this is a function of uniform motion or non-uniform motion. So you can see the time interval is 1 1 1 here, and the change in that is 3, next 1 second 3, next 1 second 3, next 1 second 3, next 1 second 3. So it means motion is uniform motion, but remember always, in uniform motion it should be that it should change the distance by equal amount for a very small interval of time. Means for this is for 1 second, and for 0.5 second this should be also by changing its position by equal amount. I will show here. And for microsecond, that is 10 to the power minus 6 second, it should be changed the position by equal amounts for a very small interval of time. Nanosecond, picosecond. Okay, then only we will say it as a uniform motion. Okay, now from here we can write for suppose delta t. For suppose delta t, we are taking two time intervals. Suppose I am writing here delta x equal at time interval x t2 minus x t1. Okay, generally we write delta x, you know, change in position x t2 minus x t1. Now here delta x for delta t, that is t2 minus t1. Here delta t equal to, I am checking in between 4 second and minus 1 second, 4 minus 1. Okay, that is for 3 second. Means what is the meaning? Delta x at x, I am checking the change in position at x, position at 3 second minus position at 1 second. Means at 3 second, what is x? That is 9. x3 is 9, and what second? That is x1 equal to 9. So delta x equal to 9 minus 3. x3 is 9 and x1 is position of the object at x equal to 3 second, that is 9, and x equal to 1 second 3. Delta x is this one, and if I divide this one by delta t, then it will be t3, 3 minus 1, means I am checking between time intervals 3 and 1. So t2 minus t1, delta x upon delta t, actually its meaning is x3 minus x1, delta x upon delta t upon 3 minus 1, t2 minus t1. So here you can check delta x upon delta t equal to 9 minus 3 upon 2. Okay, so that is equal to delta x upon delta t equal to 9 minus 3, 6 upon 2, 3 meter per second. What is delta x upon delta t? Delta x upon delta t is the average speed. Average speed of the object is 3 meter per second in time interval between t equal to 1 second and t equal to 3 second. Okay, so this is a fixed 3 meter per second. It means this is a uniform motion. But we will check it for another time intervals also. You can check for time interval between 1 and 2. So if you will check between time interval 1 and 2, change in position 6 minus 3 upon change in time interval 2 minus 1. So 6 minus 3, 3, upon 2 minus 1, 1, that is equal to 3 meter per second. So delta x upon delta t for every time interval will be 3 meter per second. That's why it is a uniform motion. But we will check. You can note down first this one. You can take a screenshot of this one. Then we will also check for the very short interval of time. Okay. Now see here, for I am checking for time interval t1, that is equal to 0 second. Suppose t1 that is equal to 0 second, and t2 I am taking t2 equal to 0.5 second in between these two time intervals. Then what is the position of the object at 0.5 second? So here we have the function xt equal to 3t. Yes or no? So x0, position at t equal to 0, x0 equal to 0, and xt means 0.5 equal to 3 into 0.5. So x into 0.5, that is equal to, I think, 1.5. This is 1.5. Okay. So now we have this is the position at x equal to 0.5. So what will be the delta x upon delta t? We can write x as 0.5. I am taking between two time intervals 0.5 and 0. So position of object at 0.5 second minus x at 0 second upon change in time interval 0.5 minus 0. So what will the value x at 0.5? This is 1.5 minus x0, that is 0 upon 0.5. So solve this one. So you will get again 3 meter per second. Means for a short interval of time, we have taken a short interval of time 0.5. The change in the position of the object means its speed is again constant, that is 3 meter per second for a small time interval of time. Okay, so that's why it is a uniform motion. Now we will check for a further short interval of time. Okay, in between 1 and 1.1 second. Okay, we can check for very short interval of time, velocity should be constant 3 meter per second. For very small interval of time, you can note down this one. Okay, now next, suppose we are checking the change in the position of the object between 1 second and the next 1.1 second, means for a 0.1 second. Okay, so here t1 equal to suppose 1 second and t2 equal to 1.1 second, very short interval of time, means the fraction of a second also, means for time difference is 0.1 second, means 1 by 10, means 1 upon 10 part of a second, 1 second. Okay, so xt equal to 3t, this is a function. So from here what will be x1? So x1 equal to 3 into 1, so x, that is equal to 3 meter per second. Now second time interval t2 equal to 1.1 second, so we have to calculate the speed at x 1.1 second. So x 1.1 second equal to 3t, 3 into 1.1, that is equal to 3.3 meter per second. Sorry, meter per second, no, meter, sorry. This is the position, so that's why this is meter, not meter per second. Okay, so what will the delta x here? Okay, or we can say delta x upon delta t. So delta x will be x position at 1.1 minus position at 1 second upon change in time interval 1.1 minus 1. Okay, so now put the values. So delta x upon delta t equal to x at 1.1 3.3 minus x at 0.1, that is 1 upon 1.1 minus 1, that is 0.1. Okay, so now solve this one, then it will become this is x t1 equal to 1 second, this is 3, x, the position x1 is here 3, so here will be 3. Okay, so 3.3 minus 3, that will be equal to 0.3 upon 0.1. Solve this one. So what we will get? You will get x again 3 meter per second. So what is the meaning? Meaning is that delta x upon delta t means V average. average speed delta x upon delta t, we know this is average speed of the object is constant for a very short interval of time, very short interval of time, means throughout the motion for each microsecond, nanosecond, the speed of the object should be constant. It should not depend on time. So that's why speed is always constant. Okay, 3 meter per second. So that's why it is a uniform motion. But here in this case we can check a point. A point we remember here. We are going for delta t equal to 0.1 second. If we will go for delta t equal to 0.05 second, then again you will find that V average is again 3 meter per second. If we will get for 0.0001 second, then again V average is equal to 3 meter per second. And you know, if limit, I will write limit delta t tends to 0, delta x upon delta t, then what will becomes? It becomes a average instantaneous speed. Yes or no? Instantaneous speed v equal to this one, and we say generally by differentiation or differentiation knowledge v equal to dx upon dt. Okay, so here we can say for uniform motion the instantaneous speed and the average speed of the object both are same throughout the motion. Yes or no? Because we are checking that the average speed means for a very short interval of time, 0.1 second, 0.05 second, it is again constant 3 meter per second. So instantaneous speed and average speed for uniform motion are always same. So you can take the screenshot for this one, then I will write the concept. Okay, so we can note this concept. You have to note down all these. Okay, so what is the concept? We can say for uniform motion, the instantaneous velocity and average velocity, of the object are same for each instant of time. Means average velocity and instantaneous velocity are same. Okay, so you can note down this concept also. Okay, now we want to put the graph and slope. So suppose the function was xt equal to 3t in this case only. Suppose this function will be xt equal to 3t square. Then you can check either it is uniform or non-uniform. Is xt equal to 3t square. Okay, means how it is, either it is uniform or non-uniform. It will change its position by equal amount. It will be uniform, and otherwise it will non-uniform. It will be 3t square will be non-uniform. Okay, so here the uniform motion xt equal to 3t. So we are putting the graph for this one, and we will find the slope. Okay, so here t and x, t in second and x in meter. Okay, so suppose 0, 1 t equal to 1, this is 3 t equal to 2, 6 t equal to 3, 9 t equal to 4, this one is 12, 5, 15. Suppose now we are plotting the graph, position time graph. Okay, so in y-axis we are taking position x, and in x-axis we are taking time in second. So along x-axis the scale is 1 1, means scale is very important in graph. You know always along x-axis, suppose 1 centimeter in graph paper, 1 centimeter equal to what is? We are taking 1 second. In y-axis we will take 1 centimeter equal to 3. 1 centimeter equal to 3 meter. This is the scale. Now graph, please. Suppose 3, 6 equal 12 and 15. Okay, this is origin O. 1 second, 2 second, 3 second, 4 second, 5 second. You all know about the graph. So at 1 this will be the point, at 2 this will be the point, and 3 This is the point, and you will find the graph is a straight line like this one. Okay, if you will plot the proper graph, then you can check. Okay, so graph will be like this one. Okay, so points will be suppose a point here, this is the next point, this is the next point, and 12 point here, and suppose this is the point. So this is the graph. So here you can see the graph for uniform motion is a straight line making an angle, making a certain angle theta with time axis. So graph is straight line making an angle theta with the time axis. So how we can find the slope? You know from class 9. So I am again telling you, we can take any 2 points in the graph, any 2 points, and we have to find the tangent on this graph. Tangent on this graph. Then suppose I am taking here, one point is this one and another point is this one at 12. Okay, so we have to make a right triangle here. We can say ABC, and angle B is 90. So we will apply the tangent of this graph. Tangent means tan theta. So what will be the slope equal to? Tan theta means we can say it m also. Okay, later on we will study the straight line y equal to mx plus c. Y equal to mx plus c. This is the equation of a straight line where m is the slope and c is the intercept. Okay, so slope is also known as tan theta. Slope m equal to tan theta. Okay, we will discuss it about later on. So m equal to tan theta. So find here tan theta. So tan theta equal to perpendicular BC upon base AB. So BC, what will the BC value of BC here? 12 minus 6. 12 minus 6 upon AB. AB, that is 4 minus 2. So tan theta slope equal to 12 minus 6, 6 upon 2, that is equal to 3. And what is this BC upon AB? This is delta x upon delta t. This is 3 meter per second. So you know the slope of distance time graph, or we can say position time graph for uniform motion. Okay, slope of this represent the velocity or speed of the object. Okay, so in this way we can measure the slope, and we can find the slope by taking any 2 points. We can take these 2 points also, we can take these 2 points also, we can take these 2 points also, and there may be another points also. So here we discuss about the position of an object in terms of as a function of time. Okay, so in the next lecture, in today's lecture, we discuss about this one. You have to make all these concept, all the notes in your fair notebook. Okay, you can make and you can take a screenshot for this one. So in the next lecture, or we can say, I want to one more point to you. Please remember here. Firstly, suppose actually what is slope here? Slope is means the tangent to the time axis here. Tangent to the angle of which graph making with time axis. So suppose this, we can check here. Suppose this is a copy. Okay, and suppose this is the time axis. Okay, time axis is along this one, and if make certain angle like this one, so theta, so tangent of this will be the slope. And suppose this is like this, then theta will be 0. Tan theta, tan 0 is 0. It means slope is 0. And suppose the object is like this one, then what will be the theta? Theta will be 90, and tan 90 infinite. Then there will be infinite slope. Means suppose xt position time graph, 2 graphs are there like this one. Suppose this is for object A, this is object for object B. Then whose slope is more? So slope, this one is more. So its velocity or speed will be more. Okay, and its slope is less. So we can say about the speed of an object by the slope of the position diagram making with the by the slope of the position time graph. Okay, so its speed or velocity will be more. Okay, So in the next lecture we will discuss about the non-uniform motion, as a how a function of time, position of a function varies as non-uniformly as a function of time. Okay, so that's all for today's lecture. You be regular in study your studies. Thank you so much.